Hi everyone. This is just a little video to welcome you into this MA 3251 or MA 52-129 Fluid Dynamics course at Bath. This is actually the first year that the course is launching, so it's going to be exciting, but also a little bit terrifying. I want to make a little video just to welcome you and to tell you about how the meetings for this course are going to be structured. All right. So we have 3 meetings during the term. The 3 contact points are going to be Monday, Tuesdays, and Thursdays. And the Monday, including on the very first week, which is starting next week, we're going to be meeting online. So if you'd like details about that, go on to Moodle and find the usual Moodle course page. There's going to be a Zoom link, and it's going to give you instructions on how you can get connected with Zoom. Okay? Just a little bit of a warning that the best way to connect into the online lectures is to download the Zoom app either on your phone or on your PC or whatever device you're using. I found that using the browser to connect in, just the web browser, makes it so that the resolution is not so good. So because we're going to be, hopefully I'll be working on the board if it's going to be nice and clear, and I want to make sure that you can read the board appropriately, okay? So let me tell you firstly about the notes for this course. The notes for this course have been released or online, but because this is the first year delivery, we're going to be updating these notes as we go. So if you go online and you click the appropriate link on Moodle, you'll get directed to this page, and we're going to be updating this page through the weeks. I'll let you know, and Dr. Tweedy, the other lecturer for the course, is going to let you know when we periodically update this as it becomes more and more complete. Okay, but so far the first few chapters have appeared in mostly complete form. The worksheets are not yet ready. We're going to be getting those together in the first and second weeks for you. Okay, I started the lecture notes with this beautiful quotation by William Thomson, who's also otherwise known as Lord Kelvin. But he said, okay, now I think hydrodynamics. So hydrodynamics is the study of water motion and water. It's to be the root of all physical science, and at present second to none in beauty in its mathematics. Right. So Kelvin famously had written these papers describing the waterways behind and under a boat, and he described this phenomena that most of you would have recognized if you just go down to the lake that we have at Bath and you see the ducks moving through the water. These ducks will make this V-shaped, wedge-shaped pattern of waves behind them. And Kelvin had described how, using mathematics, you can essentially predict the pattern of these wedges, and it's around the tip of the pattern is about twice 19 and a half degrees. Okay, and he wrote this up way back in 1887. Right? So even at the time, Kelvin had appreciated that this idea of fluid dynamics, of studying water motion, it lies at the root of all physical science, because the concepts involved in developing the equations for this theory, these equations that we're going to learn about in the course, these concepts include things like conservation of mass, include conservation of momentum, conservation of energy. These are the fundamental building blocks of so much of life on Earth and off Earth as well. And so whether you're talking about water in the ocean, water in your bathtub, water in your beer, in your pint of beer, or you're talking about oceanography or weather prediction, or all these other fields that include the study of liquids and of gases, right? These techniques that you're going to learn about this year are in a lot of ways fundamental, right? They're the basic building blocks of all that lies ahead. Okay, and also this theory of ship waves was developed in the 1800s, but Kelvin was commenting already that the mathematics that you need to study this kind of phenomena was beautiful, right? The beauty of mathematics that he wrote in his quotation. So even if you're not super excited about physics, or you're super excited about the application of waterways, the study of these equations and their associated theory lie at the heart of so much of the mathematics that we teach you at Bath, and that you might continue to learn this year and beyond. Okay, so that's just a little blurb to excite you about the course. Otherwise, I'll look forward to seeing you on Monday. All right, I'll see you then.